Hello and welcome to another video regarding these molecular models, and of course the bond lengths of these three amazing compounds, namely ethane, ethene and ethyne. You can see them. Ethane, right? This is ethene, that is having a double bond, and of course ethyne or acetylene, right? This is an acetylene molecule. Okay, so this is ethene and this is ethane. So today we are going to discuss the bond lengths of this ethane, ethene and ethyne, and the bond angles that are existing between them, because I have explained this on the paper. So today I have these wonderful models, 3D models, so I thought that I must show you these three models. And on one of my students request, I thought that I should prepare a little video to show you how they look like and how the angles and the distance between the carbon hydrogen atoms they simply are seen on by viewing them in the three-dimensional way, right? So today I am going to explain you all this, so let's start. Now, first of all, I would like to tell you something about the bonds, right? So here you can see this is an acetylene, an ethyne, an alkyne, right? It has got two carbon atoms, two hydrogens, and they are bonded together by the strongest bond, that is the triple bond, right? So let's compare it with the second molecule, that is your ethane molecule. Now ethane has, as you know, it has got a double bond between them, right? This double bond exists between these two carbon atoms. So now one thing that is something very important to note. Now let me hold these and the ethane. We have to compare these three for some instance. Now what was that? Then I wanted to just make a few things clear to you. That is, let me hold them. That is the carbon-carbon triple bond. That is this one. Carbon-carbon triple bond is shorter than the carbon-carbon double bond. Okay, let's compare two first because I can't hold three. Okay, so the carbon-carbon triple bond is shorter than the carbon-carbon double bond. Okay, and then in again this carbon-carbon double bond, now if we compare this one, is shorter than the carbon-carbon single bond. So this was something very interesting, and I know most of you know that, but you cannot visualize that in the sense of 3D structures. So I thought that I must explain it to you, that there is a difference in the lengths of the carbon-carbon bonds in all the three different molecules, that is acetylene, ethane and ethene. Okay, so now one thing to remember is that the shortest carbon hydrogen bonds, okay, the shortest carbon hydrogen bonds are related to the carbon orbitals that possess highest s character, that has the highest s character in them, right? So what does that mean? That means that the sp orbitals of ethyne, that is this acetylene, its sp orbitals, right, they have 50% s character and 50% they hold the p character in them. They have 50% s character, whereas they have 50% the p character, and that's why they have the shortest carbon hydrogen bonds, that is almost 1.06 degrees angstrom. Now what is the distance between them is 1.06 angstrom units. Okay, so this is the distance between them, and this is the shortest of all the other ones. So now the angle between this and this, right, this triple bond and this single bond, this angle, the angle between this and this is how much? 180 degrees, right? 180 degrees. The angle between this and this is 180 degrees. Fine. Whereas the length between the two carbon atoms is 1.20 angstroms, and as I've mentioned earlier, this distance is almost 1.0 degrees, 0.6 degrees angstrom units. Okay, so this was something about acetylene. Now you know the angle between them, that is this angle, and the angle that is found between them, this triple bond and the single bond, is 180 degrees. Whereas if we discuss ethane, now this is an ethane molecule. I should put away this one. Okay, this is an ethane molecule. So now if we discuss this molecule, right? Now it has 25% S character and 75% P character, right? This is what is S and P. These are all I'm talking about the hybridisations, right? I hope everyone knows. I don't want to start from the very beginning. So this is all about, I'm talking about the hybridization. So it has the 25% S and 75% P character. Fine. Okay. Now if we talk about the angles, right? The angle between this and this, right? These two, there is an angle that's forming between these two is 109.5 degrees, whereas the carbon hydrogen the longest, it, as we claim that it has got the longest carbon hydrogen length, side bond length. So what it is, it is 1.10 angstrom, right? And if we talk about the carbon to carbon distance, that is the carbon to carbon length, what that would be, it is almost 1.54 angstroms, right? 1.54 degrees angstroms. So now look at this ethane molecule. Now if you look at it from the view, if you are the viewer, now see, this bond is projecting towards the viewer, whereas these are away from the viewers, right? And these are on the plane of the page, right? On the plane of my hand, you can say. So it's the plane on the hand. So these are projecting towards the viewers. So these are called the dashed, the strong wedged bonds, right? The strong wedged bonds, solid wedged bonds, even they are called solid wedged bonds. Whereas those that are pointing away from the viewer, we are the viewers, right? So we are the viewers. So if they are pointing away, the bonds that are pointing away from are the dashed bonds, right? That are represented by like this. They are represented like this, right? This is how they are represented away from the viewer. Whereas these are the bonds that are projecting towards us. They are the solid wedges, right? And the solid wedge is like this one. This is a solid wedge that is pointing towards the reader. And that is away from the reader is the dashed bond, and these are the single bonds that are in the plane of the page. So this is how we describe a three-dimensional structure of any molecule, right? So this is an ethane molecule, and I have just explained you all the angles between them. That is, the angle between this and this is 109.5, whereas the distance between them is 1.5 angstroms, and the carbon hydrogen length is 1.10 angstroms, right? Which is the longest bond. Whereas an ethene molecule, now here it has got this double bond, you can see here again, right? So this has simply you can say the carbon hydrogen bond, that is this one, the carbon hydrogen bond length is 1.09 angstroms, right? Which is 1.09 angstroms. So this was and you can see that the distance between this and this hydrogen, this is 118 degrees angstrom. Between them is 118 degrees. The angle between them is 118 degrees, whereas this angle between this and this is 121 degrees. This angle is 121 degrees, whereas the carbon to carbon length is 1.34 angstroms, and the carbon hydrogen, as I've mentioned, is 1.09 angstroms. So this was something about the angles and the bond lengths of the three molecules, that is ethane, right? Ethane, and the third one, that is this one, the acetylene. So this was something lovely and beautiful I wanted to show you today. These are the three molecules. Now you know that the sigma bond, it's simply a type of a single bond, right? And in which you can say that the density of electron has circular symmetry when you will view it along the bond axis. So this was something also very interesting and knowledgeable for you people. I hope you like this video about today's bond lengths of ethane, ethene, and ethyne. Thanks. So I was talking about the sigma bondings and of course the electron density, and of course that it has circular symmetry when you will view it along the bond axis. And when you speak in general, the skeletons of skeletal structure of all the organic molecules are formed of atoms that are connected by simply which type of bonds? The sigma bonds, that is the single bonds, right? Now when you will simply hybridize 3p orbitals, that is the 3p orbitals with one s orbital, what you are going to get? You are going to get 4 sp3 orbitals. Okay, fine. Whereas when you will hybridize 2 p orbitals with 1 s orbital, you will get 3 sp2 orbitals. Whereas when you will hybridize 1 p orbital, only 1 p orbital with 1 s orbital, you will yield 2 sp orbitals. Now this was something about the hybridizations and something about the orbitals, a little knowledge about that also, that how the hybridizing how you will hybridize the orbitals and what you're going to get in the end. So the carbon atoms of ethyne are this one, that is this one, are sp hybridized, right? And ethyne, as it's a linear molecule, so it is it has got what type of atoms are all sp hybridized. They are all sp hybridized. Whereas the carbon atoms of ethene, that is this one, the ethene, they are all sp2 hybridized, and they are all trigonal planar, right? They are all trigonal planar. Fine. Whereas if we talk about this one, the third one, this one is, for example, if we talk about the methane, the carbon atom methane is sp3 hybridized, and it has got the tetrahedral geometry, right, which I have explained earlier also, so I do not need to explain methane again. I was today interested in explaining you simply ethane, ethyne, and ethene. So I hope you like today's video and you enjoy it, and you have learned, because somebody asked me today that I should explain them, the bond lengths and bond angles of ethene, and ethyne. So this was all about the angles and of course the bond lengths of these amazing, beautiful 3D molecular models, right? So I hope you have enjoyed learning them. And now I have also explained you one thing, that is what are those type of bonds that are projecting towards you, what they are called, that are away from the viewer, that what they are called, and then the third one that are inside, in the plane of the page, what they are called. So I've explained all those 3 types too in this video. So that's all for today in this video. See you again with something interesting, something new, something more knowledgeable, and which I am interested in. I'm going to explain that thing which I am interested in more, because when your teacher is interested, when your instructor is more interested in a particular topic, he will explain everything to you in a very nice way, in a very informative way, the way you will going to absorb each and every point clearly. So thank you very much. So I'm signing off now. See you next time. Goodbye.